6. And it's not as easy as I kind of just gave you.
What page is it?
Number of US
1037.
1037. Boom, I turned right to it. What's the probability of me doing that?
Astronomical.
Astronomically
low.
2 pages, so
Alright. Checkpoint 6.
yeah, like 50%.
I was on page
You have to have
1047.
them all up.
191.
We went there. Yeah, I
31,
turned right through it.
191.
Yeah, it was on whatever page we were at. 43.
Checkpoint 6. One driver is randomly selected from the population represented in figure 1112. That's that big colorful circle or wheel. Find the probability expressed as a simplified fraction that the person is not in the 50 to 59 age group.
83.8%.
Yeah, because all you have to do is take the probability that he is in the 50 to 59 age group and subtract that from 1,
Which
right?
is 31 divided by 191 and then minus 1.
There you go. See,
Or plus.
it's a pretty easy concept, but they find ways to make it a little bit difficult. But as you'll see from the homework quiz, we don't really use those in our quiz. We don't use the difficult measures in our quiz. All right. Okay, 2 more topics. One of them won't be on the quiz, and the other one will. And unfortunately, the last one will be on the quiz, so I have to go through it all. All right. Now, a mutually exclusive event. I don't have any room to write it on the board, but where's red?
You wrote your empirical
You're in my empirical problem.
on the other side. Your empirical probability.
Now, for you computer people, programming types, you've heard of ands and ors, right?
Yes.
Probability has ors and ands and ors too. We're going to talk about ors first.
And
Or probabilities, such as probability of A or B, right?
And not.
So probability of, yeah, we have knots too. Yeah, probability of A or B. Meaning, hey, probability that event A is going to occur or event B is going to occur. Now, if I say A or B, what does that mean?
One or the other.
They cannot happen together, right?
One or
Or,
the other.
in other words, we're saying these are mutually exclusive events.
Everything over the other.
Mutually exclusive events, meaning cannot happen simultaneously. All right. Mutually exclusive events. So, probability A or B, if it's mutually exclusive, if they are mutually exclusive events, yay, because that makes it easy, it's simply
One or the other.
no, 1 plus the other. The probability of A plus the probability of B.
Keep going.
No, not for mutually exclusive. You're talking about for not mutually exclusive.
Oh, yeah.
That's because, hey, they can't happen at the same time. Right? So, hey, the probability of A, probability of this happening, plus the probability of this happening is my total probability. Okay? If they're mutually exclusive. Now, what if they are not mutually exclusive? That means they can happen at the same time, right? Let's take cards, for example. Mutually exclusive event. Say you're going to select, what's the probability of selecting a 5 of clubs or a 7 of diamonds? When you select one card. Can you select them both at the same time?
No.
No. All right. That's a mutually exclusive event.
So that's 1 in 52. Plus
What's
1
the
in
probability of selecting a red face card?
That's 26
I
or
mean,
52.
a red card.
Or red face
A
card.
red suit or a face card. Now, you can select a red suit and a face card at the same time, right? Because it's a red face card, right? So that would be non-mutually exclusive because it can happen at the same time. You understand? So if you're doing that, I need red. I don't have red.
Yeah, you do.
Where? No, that's black with red top. Ha ha. Non-mutually exclusive, a non-mutually exclusive or looks like this. Probability of A or B equals the probability of A plus the probability of B minus
The probability of A and B.
the probability of A and B. Why do you think that is? The reason why is because, hey, let's talk about probability of red card plus probability of face card minus the probability of a red and face card. Because you don't want to count them twice. If they can't have it at the same time, you're not counting them twice. But if they have it at the same time, then you're going to count it twice. So you're going to subtract it, so it only gets counted once. Luckily for us, this is the one that you don't have to worry about. That's what throws everybody off. This is cool. Everybody understand that?
So that's
Let's
what
do it.
probability of them happening at the same time.
That's probability. That's probability of yeah, A or B, and if they can happen at the same A or B, if they can happen at the same time. Not the probability of them happening at the same time. Probability of them happening at the same time is just this: A and B. A or B means hey, either or. But they can't. If they can happen at the same time, you have to subtract that probability because we're saying A or B. If they're not mutually exclusive, if they are mutually exclusive, it's just probability A, probability B.
You wouldn't add that then?
Why would you add it?
Because you can get A or B, plus you can get them
So
together.
then you count it twice. So that's where you have to subtract it. Just take probability of A. Okay, let's go red. Let's go red card. Right? How many red cards do you have in the deck?
26.
26, right? How many face cards do you have in the deck? 12.
Yeah, 3 times 4 is 12.
Not counting the aces.
Okay, 12. Right? The ace is the face card. So no eyes on it.
No.
Okay, anyway, so yeah, well, I can write this down. So it would be 26 out of 52, that probability, right? This is
12.
12 out of 52. All right.
Minus
How many red
38.
face cards?
26.
Red face cards?
Red face card?
6, right?
6.
Yeah, 6. So 6 out of 52. That's the probability of red and face cards. Now, why do we have to subtract it? Because you want to add it. Okay, we counted these already, right?
Yeah.
Actually, we counted them twice if it can happen that way, right? Because 6 of these are in here
Already.
and 6 of these are in here, and 6 of these are in here.
Right.
The same 6. So we're like, we don't want to count them once, so we subtract. That's a good question. That
So you end up
helps
with
illustrate why you have to subtract that. Normally I'd say, hey, so you always got to remember this equation, but like I said, the quiz is you don't have to worry. This is the hardest one, but luckily for you, we don't have to worry about it that much. But we do have to worry about and. Now, do you understand the concept of and? We just said if two things are going to happen, A and B, right? Probability of A and B. You just take all the events, right? That's how we got 6 out of 52. What if they are independent events? This is to me, especially when I was in statistics, this is the greatest rule to remember because it's the easiest one. If they're independent events are events that don't affect each other's probability. Like, there's probably maybe like a 0.01 probability that I might fall down right now, right? There's probably like maybe 0.0001 probability that Josh might fall out of his chair right now, right? So what's the probability of me falling down and him falling out of the chair?
Even worse.
If they're independent events, you can just multiply them together. So independent events. Probability of A and B equals probability of A times the probability of B. You just multiply them together. And that does make it smaller. Like, you know, when you multiply decimals.
So what's the probability you're going to fall down again? After that.
It's still, the probability I'm going to fall down is still the same. Probability he's going to fall is still the same. But the probability of us both falling down is pretty remote.
So that's what
Yeah. And the reason why
After
independent
you fall
events,
once, the
independent
probability
events
you
actually
fall
comes
is
up the
higher.
most in life because most stuff's independent of others. The probability of some things happening is pretty independent of other things. That's why you'll see them, they'll figure out the probability of something. They'll say, well, the probability of that happening is because they just multiply the two probabilities together because they were independent events. But most of the time, stuff is independent events. Hey, what if I'm flipping a coin? Right? What's the probability of me getting heads?
50%.
Okay, what if I flip it again? What's the probability of me getting heads?
50%.
What if I flip it again?
50%.
What if I flip it again?
50%.
Are any of those events changing the probability of the other one?
Yes, well, why if you flip the coin over on the tails and then flip it, it's more likely to land.
It doesn't matter. You only have a 50%.
I don't even know what you just said. You said flip the coin over on the tail and then it'll spin.
Supposedly, if you have tails up and
And
you
you
flip
flip it,
it,
yeah, like it'll
it's
land.
gonna land a certain way.
Like
If you
yeah.
have heads up and
Yeah.
you flip it, it's gonna.
Yeah, it is.
That's
If you catch
because
it,
you can't flip it the same way every time.
That's
Yeah.
the
That's the
no.
thing.
Still,
If
the
you had
probability
it
is
at the
still
same
1 out of
If
2.
you had a controlled flip, like
Yeah.
if you had a little actuator that flipped it with the same
Yeah.
force
yeah.
every
pretty
single
good.
time, it would,
Have you
it
ever
would always
get
be
pogs
random.
from back in the day with pogs? Like I used to get people pogs by flipping it by saying tails, by flipping it
No.
with not a lot of inertia.
That's just luck. That's just luck.
Have
Anyway.
to ask, no question, or
You got a
the only dumb
50%
question
chance
is
of
no
winning.
question. Sorry.
Well, okay.
No,
And
no,
this is on the homework quiz. So they're independent events. So if I do it 4 times, what's the probability that I
it's the
get?
same as the first one.
I just multiply them together.
50%
0.5 times 0.5 times 0.5 times 0.5. Like if I said, hey, what's the probability of me getting heads
0.25.
every time?
0.5.
What's the problem for me flipping a coin 4 times and getting heads? 0.5 times 0.5 times 0.5 times 0.5. Because they're all independent. If I get heads the first time, that doesn't change my probability of getting heads the second time.
0.0625.
That's for 3 times, right? No, that's for 4 times.
4
3 times is
6%.
0.125.
0.125.
And that's it. Oh, I didn't even-
Like Rain Man.
You got a coin?
Do I have a point? Are you gonna balance it? I don't have a
No,
point.
I can show you what he's talking about.
Yeah,
What is he talking about? Say it again.
just because like I was really here doesn't mean I don't know what I'm talking about all the
I
time.
bet you can't do it. I bet you can't do it.
Heads is up, tails is up.
But all you did was turn it over 1 time. You didn't look. If you flip the coin like that, and for somebody, they'd be like, "Oh hell no! You gotta flip the coin up in the
Tails is
air."
up.
Nobody's gonna flip a coin like this. You gotta flip it all above your head. That ain't flipping a coin. You turned it over.
No, I didn't. I didn't. The heads is up. I'll flip it no matter where it goes, catch it. Tails is
But
up.
that's just probability. You're not making it do that. Put some money on whether it's gonna be heads or up and tails is up. See if
Tails
you
is up.
believe that.
You won't get that every single time.
Oh, pass it back to me.
It's the direction that
I'm
it's
doing it
spinning.
different
When it
this
lands at your hand, it's gonna land a certain direction. Now, if I throw the heads up.
But
it
you
spins
can't. You
up.
can't control that.
It's pretty controllable.
Yeah, it's controllable if you cheat.
No, you have to cheat.
If you have tails this way, and it's
Look,
flipping.
if you're counting,
If you had heads this way, flip its heads. It doesn't matter.
and if you say it's controllable, I would say that you don't have a large enough sample size to say that it's controllable. If you keep doing it, you're not. It's not going to be so controllable. You're moving it.
At one time.
This is like one dude. He's like going, "Hey, you want to
Because
take
it rolled back in your hand.
If you catch it, when it'll lift that way.
It's gonna flip and land every time. No, you have to wait. As soon as it lands, stop it from spinning.
4 times in a row or black?
Like at least the
The
outside.
other color. Next time. I did.
He doesn't. I was like, how did that
And
happen?
he's like, "What happened?" I was like,